Welcome everybody. My name is Jaebum Jung, and I'm one of the developer of Graph Network in Wolfram Research. So today I'm gonna talk about the graph visualization. So here's the outline of the today talk. So I'm gonna start from graph layout and then how to style the graph and some functions that help to visualize the graph. After that, I'm gonna giving some examples of the visualize the graph. So first, the stage of visualization is the graph layout. What it is it actually just compute the coordinate of vertices when you draw the graph. So we have 4 different stages for layout the graph. First one is the vertex layout, is how to embed vertices, its actual coordinate. After that, there are edge layout stage, which is kind of how to draw the edges. And then packing layout, this only applied when graph is disconnected. So we have bunch of connected graphs together, then the packing layout, the controlling how we packing all those different the component. And rendering order is the for ordering which one draw first. For example, like you can draw edges first and then vertices, or vertices first and then edges. So let's see some examples. So vertex layout, we have several the layout algorithm you can use, like a spring embedding, spiral embedding, etc. Here is the example of the vertex layout scheme. Also, each vertex layout scheme have like sub method. For example, like here for balloon embedding, which is good for tree graph, have like root vertex sub option, for example. So what it does is you can specify the root of this tree drawing, balloon embedding drawing. So here 1, if you change it 2, you see the center, this will be 2 in these cases. And the default value of the vertex layout is automatic. That means it kind of checking the property of graph, like if it's tree graph, it will use the like layered embedding. If it's like a path graph, then it using the like discrete spiral embedding like here, etc. And next, the scheme is edge layout. So we have like 3 different edge layout scheme. First one is divided edge bundling and then hierarchical edge bundling. Last one is, I don't specify here, is the straight line, straight line, which just basically just using the straight line as the edge. So let's look at the divided edge bundling. So this is the scheme that just, for example, like here, you have like 4 edges kind of close together. Divided edge bundling, actually just bundling these edges. So here, I just specify edge bundling, divided edge bundling. As you can see, you see these closed edges are now is come together. So giving a little bit more freezing the visualization when there are many edges. So here's another example. Also, you see this one, it looks a little confused, but here a little clear. And then hierarchical edge bundling. So this is another bundling scheme based on the hierarchical tree structure. So here's some random graph, and then if you specify hierarchical edge bundling here, then it's kind of, using the graph community. So let's see, highlight graph of this. Then you see this community kind of get together, and edge is kind of bundling together. So hierarchical structure and automatic in this case is just kind of doing the one level. So you're just kind of grouping the vertices in the same community as one level, and then using those structure, we kind of bundling the edges. Okay, now the packing layout, like I said before, this is for disconnected graph. So for example, like here you see many disconnected paths. So depending on the packing scheme, you see the difference, like the closed packing center is kind of centered, closed, and layered, layer by layer, and layered top. We start from top. This is layered nested grid. So it's kind of grid. And then rendering order. So vertex first, if you're using this but first option, then it draw the edge first and then vertices. So vertex first means vertex is on top. So let's see the effect. So in this case, you see vertex is on top of the edges. Whenever edge goes down, below or up, always vertex draw on top. And if you do edge first, then as you can see here, edge is over the vertices. Also, you can specify some order manually. For example, here, so rendering order 1, 2 means you draw vertex 1 first, and then 2, and 2, 1 means you draw vertex 2 first, and then 1. So you can manually controlling how the edge and vertices drawing in order. And then now is for styling the graph. So I'm gonna start from vertices. There are several options you can control style of vertices. First one is vertex style. This is the option to specify the directive of vertex. What I mean is like, for example, here you set the directive edge form red thick and the actual the color as orange. Then you can change the style of vertices here like that, orange and the red thick, the edge form. And vertex shape function is the option to specify the how to draw the vertices using function. That means this one has argument. So first argument will be the coordinate, and second argument is the name, vertex name, and last one is the size of vertices. That will be specified by the graph in uniform language. But we also have predefined vertex function. So like a capsule, circle, and concave diamond. So for example, here, if you're using the concave diamond, vertex shape will be concave diamond. This is function, so if you change the vertex size, this is automatically changed. And this one is come very fun if you're using the custom vertex function. Like I said, argument for vertex shape function is the coordinate center coordinate, vertex name, and size. And if you define something like this, so for this one, the default is circle, and then now you just specify this function as the vertex shape function, then you can see something like this. This case is like kind of dynamic vertex function. And vertex shape is the another shape function, but in this case, instead of provide the function to draw vertices, you can just giving any like image or graphics, whatever you want. For example, this one, I just using image as the vertex function. So shape sunflower, just picture of sunflower, for example, and then specify vertex shape, and it automatically using this image as the vertex shape. Or you can use like graphics 3D in this case. And then in this one, I just using if the vertex name is even, then using this one, if odd, and I using the red. So like I said, vertex shape can be 2D graphics, image, or 3D graphic, and this is another vertex shape example. Like you can change using predefined, or like I showed, you can use the custom vertex shape functions. And next will be the vertex labels. It's about how to label the vertices. So for example, here's some basic example of labeling using the name. You can also using the vertex way or index as the labeling if you specify. But so if you just using the vertex labels goes like a name, for example, here, so placement is kind of doing some automatic detection of the layout and try to use some best one. So like a bipartite embedding, the labels on the left and right like this. And in this case, instead of fixed position, it go around it. So make it better viewing. And here also the same thing happened. But also you can specify the specific the location using the placed. So here's the how the placed works. So placed and then label you want and location. So location can be like the symbolic position like here, before, after, below, above. Also here left top, which is specified inside of vertex, and also combination of this like before, below, after, below. And other way to specify, instead of this symbolic position, you can specify the numeric value like this. And here's the example of 1,140,0. And graph styling, next one is the edges. So same as vertex style, you can use edges style to styling edges using primitive. So in this case, I just gonna use thick brown as the edge style primitive. Then you can see use the edge is the thick and brown. So edge shape function, same as vertex shape function. This is function to draw edges. So it accepting two arguments. First one is the coordinate, and then second argument will be the edge, the edge name. So again, we have predefined edge function, arrow, box line, carved, etc. Many predefined function. So like for example, if I using box line, this is the edge you see. And here is the custom function. So first argument is point, second argument edge. Color is something that I just using for me for this function. So for example here, this will be point, first coordinate and then edge name, and then this is color that I want to use. And then this is the custom edge function you can see. And label, same as vertices. This is for labeling the edges. You can use name, edge way, or index as the vertex labeling. So here is the case of name. And also you can use place to change the placement of vertex edge labels. For example, like you can use start, middle, edge. So basically here, I just gonna use, so instead of just name, you can say placed. With the position you want, I'd say end. Then you can see edge labels is okay. I think it's because of the, let me see. It should be string. Yep. Okay, so it just showing up the end of edges instead of middle as the default. And then you can use right, left, and then combination of right, these two, right and left start. Also, you can also using other, like instead of this position, you can use like a leper, like tooltip. That means edge label now show the edge tooltip. So if you move your mouse over it, you can see the labeling. And also the numeric, the positions, 1/2, 0,0, for example, like this. And another styling is the edge using the wrapper. So there are various wrapper you can use for styling the graph, like annotation, buttons, event handler, hyperlink, or like opening the website and labeled for giving label. It's same as vertex label, edge label, pop-up windows, test area, and style tooltip. For example, like here, instead of using edge style or vertex style, you can just directly using the style when you construct the graph. So here you see the thick blue style and then the red vertices. And here's I just using button and pop-up window. So this is the vertex one. If you click, you see the it print button like I specified. And then this one, if you click, which one is this? Okay. Yep. So this is 1, 2, and then you got the pop-up window. Okay, so I have a question about higher dimensional graphs that don't project well to simple 2D image. Is it possible to view a given rendering layout from different viewpoint interactively or by manipulating some parameter? So those case, the easiest way will be using the graph 3D. For example, let me just draw here. So we have some random graph. Sorry. Oops. Right. Let me just increasing 50, 70. Right. So this is 2D, but if you do the 3D, graph 3DG, now you have 3D graph. In this case, you can rotate whatever you want. And then also for projecting, if you do, this is the 3D graph, right? And you can actually projecting this 3D graph, the 3D coordinate to 2D using whatever projection you want. So I don't think it's difficult to making those things. So you can do like you can make some kind of projection matrix, right? Say project M. This is matrix for projection, and then you can just do coordinate. Then you got the 2D coordinate. Then after that, you can specify graph. Okay, G comma vertex coordinate goes to this. Then you can get the some projected the image of this graph in 2D using these 3D vertices. Okay, next one is about the plot theme. This is like a predefined plot theme that visualize whole the graph image, like many combination of styles. For example, like this is automatic plot theme. And the business, you can see the changing vertex style and edge style. And this one automatically labeling. And this one for marketing, it looks like that, changing the background and vertices. So it's just easy to use. So if you do like plot-theme diagram black, it's just giving the black diagram with the label automatically. So there are many, this is just, small set of the predefined plot theme. There are more plot theme you can use, and then we will giving the more plot theme in the future for user. And now I'm just showing the function to help the visualize the graph. First one will be the highlight graph. This is very useful if you want to highlight some portion of graph, like a vertices or set of edges or subgroup. So we also, like a plotting, we have highlight graph style that predefine different style of the highlighting. So automatic is this is dashed, dotted, and thick, and etc. So here's some example. So original graph G is the graph with balloon layout, and then I want to highlighting some shortest paths in this graph. So this is the original graph. This is highlighted one with the default, the highlight scheme, the automatic. And then here's another one, DOM graph. And then in this case, I just do the partition of the graph and get the subgraph and highlighting each subgraph. In this case, you have like a collection of set and highlight graph automatically using the different color for each subset. So, and then this is the result. After that, there are another function, graph community plot. This is the function to help you visualize like a community inside of graph. So here you start from the Jacare Karate Club, one of the empirical network, and then automatically it compute the community and show grouping each community together and visualize it. And here's some option you can use for this. So you can change the boundary of community and also the style, the color of the inside of this blob. And then labeling each blob, group 1, group 2. And then also you can do the legend. And I think the charts the last week show some of this function like graph plot. This basically just, help you plotting the graph. For example, one of the big differences, we have some kind of limit, not the actual limit. We kind of have set some limit to drawing graph because this is kind of large graph, so we don't want to just show it right away. But graph plot, if you're using graph plot, you can just ignore those limit and then drawing. One of the reasons we don't, when its graph is large, it's kind of useless to showing this large graph. But graph plot, no matter what, it will be plotting. And as you notice, this one actually is a graphics now instead of its graph. So you cannot do any computation after using the graph plot. That's one thing. And graph plot 3D is plotting, but as the 3D. So it's automatically converted to 3D graphics. And another family of visualization function is the layered graph plot 3D, and tree plot. This is all very useful for tree graph. So layered graph plot, you can specify, input point can be graph or settable edge or settable rule. This will regard as edges. And the second argument specify the center or root. I'd say just automatic. And the left is let's see. So this one gonna be left. Default will be top. So it's the layered graph from top to bottom. Or you can say top, left, right, and then it starts from right. Here's the root, automatic, in this case, vulture. But if you can also change the root like lion, then you can see lion on the right side. A layered graph plot 3D is kind of similar to layered graph plot, but now you can plotting it 3D. Also, in this case, you can see the layered, like vertex graph layer style pastel, which is colored. And then also you can see the each layer as graphics. You can turn off, okay, you can just set what you want using the options, but this is default. And then tree plot, another plot for tree. So if it's the large, it automatically select radial embedding, or if it's the just kind of small, then it will go the layered embedding. So that's kind of different, but same thing, you can specify the root and then position. So in this case, I just do the center. Another function, this is not documented, it's kind of, we will introduce in the future, but it's in the system, you can use it. So one of the function is graph property chart. So if you just input the graph, it's all the some specification automatic goes to it using vertex out degree value to draw the chart. And this is the result. So you see this edge going out from protocol to others. So basically, one of the benefit of using Wolfram language is like you have many other different area of functions. So for example, like we have many the different charting functions. So in this case, we're using pie chart, and it's not that difficult to combining those functions together. So in this case, we combining the graph visualization and then the charting function. And this is the result you can see here. And this one, in this case, you want to compare multiple, the property of graph. So here this is 1, 2, 3, 4. And then in this case, using this kind of stacked pie chart. So it's a degree centered eigenvector. Also, here is the graph inside. And then another function is clustering radial chart. This is kind of useful for social network analysis. So I just say Jakarta club. And then if you using this function, so here, so what it does is kind of grouped by community. So you can see, let me just a little bit make it bigger. And then this sorted by vertex degree inside the community. And here, if you're getting it, it has higher some value. It default using the between its centrality. Also, you can specify by your own dot community. Also, now I want to compare degree centrality for the radius. So like, okay, let me see. In this case, same is the ordered by vertex degree. And then when you have higher degree centrality, it goes toward the center. So this is the graph clustering radial chart. It's still in development, but you can use it. But the design might change it in the future. When it documented, you can see what exactly it does. So now look at some the interesting examples. So I think last week Charles showed you some of these examples like the maze. So this is let me just build some maze using the graph. So start from grid graph and then get the spanning tree out of it. And using this spanning tree, you can build some random maze like this one, yes. And I want to find solution of this maze from starting from here, starting and then ended here. It can be very easy. So for example, like a here solution from here to here, it's not that difficult using if you just find shortest path. There are several ways to show this solution. You can just do the highlight graph with this path like you see the last week, or you can do some kind of interactive, I mean, the dynamic visualization. So I just gonna get the coordinate of this tree and define the function to computing kind of position along the shortest path. And then V function, this is the function that I used to, in vertex shape function. And then I just combining this together, the maze and the graphic with some clock, the dynamics. And then you can see here, it looks like some kind of spider, but it tried to go through this maze and then eventually it will be arrived here. I just using some parameter, like it will take 20 seconds from first to the end, and it will show like 2 times, right? It end of one and then it go to another one. So for example, in this case, you can just using the manipulate or event handler to trigger this solution movement if you want, but it's not that difficult, like I said. Okay, let me see there are a question about. So many of these things apply to acyclic graph only. Any wisdom to share about displaying cyclic graphs? Generally, just to mention particular function and options you found useful for presenting cycle graph. Okay, so yeah, the layered. I think this user talking about the layered graph plot, right? Yes, layered graph plot is very useful, mostly useful for a cyclic graph. For cyclic graph, I mean, I think it depends on how you want to show the cycle graph. For example, like if you just want to emphasize the cycle inside of graph, you can using the function like find cycles and using the highlight graph and the highlighting cycle. But if you want to draw the graph, cycling graph, I think like the spring embedding or spring electrical embedding can be used for those graph. because those graph can be easily draw those kind of like a cycle inside of it. Or if it's the planar, then you can use planar embedding to draw those kind of graph. So it depends on what you really want to visualize. Okay, next example will be this Marble Universe social network. So this is the social network that I built from example data. After some massaging, this one, actually this edge represent the hero, and then there is connection if they showed up the same comics. So this is the graph of those connections. It looks kind of boring. So here's the series of options that I'm gonna use to visualize this graph to make it better. So I get the vertex list first. So as you can see, this is the just name of hero, right? Long list. And then I find the centrality. I just using the degree centrality. You can use any centrality you want. And I just gonna using pick up the top three centrality. I mean, top three hero. They're using the highest centrality, which I interested in. So I say Captain America, Spider-Man, and then Sing Benjamin J, GR. And I'm gonna control the vertex size, change the vertex size using the centrality. So I kind of rescaling the centrality from 0.04 to 16. And here, vertex size, if you specify this vertex size like this one, using the curly bracket, for example, 1, that means I'm gonna use the vertex size based on the coordinate. So if you just using 1, it's kind of relative scaling based on between the distance of edge. But if you use 1, it doesn't matter no matter what, it's gonna using the 1, size 1 and 1 in based on the coordinate system. And then the labels, I'm gonna use tooltip for default, and then only use this placement for top 3 labels. Same thing, label style. For default, I just using the black, but for top 3, I'm gonna using this different, the label style, edge style, and then this is vertex style like I did here. This is default vertex style, but for top 3, I wanna using the different vertex style. And here's the layout scheme. I'm gonna using rendering order. The reason is that I want to stand out the top 3. So I'm gonna draw top 3 at the end. That means no edge will be over the top 3 vertices. And I'm gonna using divided as bundling layout and close packing center as the packing layout and string electrical embedding for layout. So let me evaluate all those. And then, oops, I don't need this. And final, the graph will be this, which looks, in my opinion, is much better than this one. Wait, this one, the first original one. And so top 3, the size is based on the centrality that I compute. This is top 3 vertex size, and then this one labeled as the tooltip. And you can clearly see the top 3 vertices. And next example will be the snap. Snap is tempered the social network, the database. And I just grab one from there, is Facebook database. And then do the little massaging to make this data set. So basically here, this one containing graph of some Facebook social network, and circle is kind of grouping, and some of features for each vertices. So I want to just easily see some of feature contained in this data set. First one that I do is I just making the chart using the feature. So each vertex have the feature which is kind of encoded. So what I did is I just get the total of each features. So each vertex has same feature, some feature doesn't have it, some feature it has it, and then I get the total. Let me just show. So here's the feature of first graph in this data set. So here, this is total of each feature for each vertices, right? It has locate 1 to 7 is the most feature that each vertex has. And then this line represents the one with highest vertex degree. So I just want to see the relation between the overall feature and the one with the highest vertex degree in this case. And this is some kind of table. They show you the basic property of the graph. So like a node, edges, clustering coefficient, and then the diameter and number of triangles, etc. And this one is the actual visualization of graph. So for example, like here, the vertex size controlled by vertex degree, and then also the color. And here you can also see vertex degree by size, and actually this color is grouped by the circle. So instead of just see this one by one, I'm gonna just put all together using the manipulate to make one big control panel. So this is the result of manipulate. Take some time. Oops. There's some error happen. I think the version I have some issue maybe. Let me just reevaluate it. If this doesn't work, I might probably need to keep the color. Yeah, there are some issues. The version I have. Sorry about this. I'm gonna just change the mathematical version maybe. Let me just see. Okay, I make this work. Yep. So this should be the output. I probably just using the wrong version, so it has some error in the corner. So, but this is actually manipulated if you evaluate this one, and you can change the set of the graphs, the first one and second one, Facebook, and then you can change the centrality you interested in. So vertex degree between its centrality, close centrality, and then you can turn on and off the feature like this one, feature bar chart, also summary of each graph. And also you can the color by the centrality or by circle. So each circle have the same color. So you can see how the community on this graph. And also you can change other graph. Some graph is large, so it takes some time to show up. But yeah, eventually this is another one. So you can change the centrality by color and turn up summary. So this is the last example I show you today. So I'm gonna see if there is any more questions about visualization. I'm gonna wait a little more if there is any questions. Okay, so it seems like there is no question so far. So I'm gonna wrap up today's talk. So thank you for joining the talk today. And I hope you enjoyed. And I think next week, Charles will talking about the social network analysis, like you see here. He will talk about this, all those centralities and the tool to do analyzing the social networks. So I hope you will join that talk too. And then thank you for attending again, and hope to see you again. Bye.